So far in all the videos talking about the growth of functions, we have assumed that the function takes on positive values. In other words, I had this assumption here that the function f is asymptotically non-negative, that from a certain point on the x-axis, all the way down to the right to infinity, f of x becomes positive. Now the question is, what about negative functions? For example, what about minus x and minus x squared? Of course, minus x squared is a smaller value than minus x as x grows. But what do we do about that? Do we say that minus x squared is big O of minus x, or what? The answer is no, we don't say minus x squared is smaller than minus x, because remember, we are not talking about the value of the function, we are talking about the growth of the function. Which one grows faster than the other? So if I want to start talking about functions that might take negative values, I don't have just, if I talk, for example, about f and g, both of them are from the reals to the reals. Not assuming anymore that they are asymptotically positive. And if I want to define f being O of g, now if I want to allow for the negative case, I can say that f is O of g if there exist constants c and k such that the absolute value of x is smaller or equal than c times the absolute value of g for every x greater than or equal to k. Okay, so now we put the absolute value. Now we look at if f is, again, minus x and g is minus x squared. Again, if you take any x there, minus x is if you take the positive value. So like I look at x greater than or equal to 0, for example, the non-negative value. Of course, minus x is larger than minus x squared. But when we talk about order of growth, we want to say that the minus x squared, it is still a function. If I look at its curve, it is growing faster. And this new definition with the absolute values there allow me to do that, because if you look at the absolute value of minus x, it is smaller than some constant times the absolute value of minus x squared, right? Because this is x and this is x squared, and then we go back to something similar to x being O of x squared. The same thing would be with the omega. You will basically say f of x is greater than or equal to c g of x, and the same thing with the theta. The absolute value of f for theta would be smaller than t, the absolute value c2 times the absolute value of g, greater than or equal to c1 times the absolute value of g as well. Okay, so if the functions, for general functions, if the function can take negative values, for example, we can use the absolute value. Notice that when the functions are asymptotically positive, you can drop these absolute values with absolutely no difference. But if somehow you are dealing with functions in a realm where you are dealing with negative functions, they are not asymptotically positive, then you can still adapt the definition very, very easily by using the absolute values there to still maintain that notion of speaking about which functions have different orders of growth. And it's really just about using the absolute value around f and g.